Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the radiation force acting on a cone. So let us see that this is a cone which is perfectly reflecting, as its reflectivity is 1 and absorptivity is 0. So imagine a cylindrical beam of radiation of intensity I incident on this cone, and I have already drawn a cylindrical cross section of this cylindrical beam. So you can imagine this cylinder, and there is a strip on the cone surface, and the width of this strip is dx, and this distance is x of this strip. Now the total height of the cone is h and the radius of the cone is r. These data are given. Intensity of the beam is A. Now first of all, let us find out the area of this strip, and let us say that this is the radius of the strip. So by similarity of triangles, we can say that if this is the slant height L, so by similarity we can say that R by L is equal to small r by x, and therefore small r is equal to rx by L. This is the first equation. Now let us say that the area dA, this area of strip, this area of the strip is equal to dA is, or we can name it as ds. So ds is 2 pi r into dx, and ds is 2 pi r is rx by L into dx. This is the area. Now we know that the force carried by this beam is in this direction. The force carried by the beam in this direction, and this is the area dA, this perpendicular cross-sectional area of the beam. Okay, so what is dA? dA is actually this area, shaded area. Okay, so dA will be this area is ds and this is dA. So you can say that this angle is theta. If this is theta, so this component will be ds sine theta. So dA will be equal to ds sine theta. So dA will be equal to 2 pi r x dx by L sine theta. This is the cross section area of this beam, and the force carried by beam. This force carried by beam. What I mean to say is that the fact that when some perpendicular object is kept in the path of the beam, then this beam will apply this force on the object. So this force will be equal to I by C into this area dA. So this force carried by the beam is F. Let us suppose that it is F, and it is I by C into dA. dA is 2 pi r x dx sine theta by L. This is F. Now we know that this is the change in momentum per unit time in this direction. So we know that as these electrons will be reflected, because it is a perfectly reflecting cone. So let us draw it again, that these electrons will be reflected on the surface of the cone. I'll draw the cone again. One second. This is the cone, and these electrons are striking this surface, and these are reflected by this. So the change in momentum is in this direction, and this angle is theta. Okay, and therefore this angle is theta. So this is 90 minus theta, this is 90 minus theta. So the force acting on this cone is in this direction dF, and dF will be equal to uh, the component of this force. This force is F in this direction, so F cos theta and F cos theta. What I am trying to say, that the change in momentum dP is F dt, okay, in this direction, but it is reflected, so the change in momentum will be equal to 2 dP sine theta, and dF will be equal to 2 dP is F dt, so F dt sine theta, and dF, this is the change in momentum, net change in momentum. So this will be equal to net change in momentum per unit time will be equal to 2F sine theta. So this will be the net force acting on this strip of the cone, so it would be dF. So dF will be 2F, and F is this one. F is 2I by C pi r. This is 2I by C pi r into x dx sine theta by L. X dx sine theta by L. Now we know that the force acting on this strip will be net force will be only the component, because dF is also acting, dF is acting on the complete strip, and therefore we know that these components will be cancelled out, and the net force will be, this angle is 90 minus theta. So the net force acting on the cone will be equal to integration of dF sine theta. So it would be equal to 4I pi r x by c, and this is L, and dx and sine cube theta. So this x by L is again you can say that in fact this r by L is sine theta. So this would be equal to, F net will be equal to 4I pi by c, and sine to the power 4 theta is common, and integration of x dx is x square by 2. The limit of x will be from 0 to L. Okay, so F will be equal to 2I pi by c, and sine theta will be equal to, sine theta is obviously, we know that this result is 2I pi by c. F is 2I pi by c, and sine to the power 4 theta, let us write it down on the next page, and sine theta is equal to r by L. So this will be sine to the power 4 theta is r to the power 4 by L to the power 4, and x integration of x square will be this L square. Okay, and cancelling this L square with this, so F will be equal to 2I pi by c, and this will be r to the power 4 upon L square. So we can write down F as 2I pi by c r square into sine square theta. So this would be the net force acting on the cone. Now if we say in the second part that, let us say that r is 0, a is 1. Now the cone is perfectly absorbing. So what we have to do is the fact that the force carried by this beam is this one. This is 2 pi r I by c, Let us first of all write down the force carried by the beam. F is 2 pi r I by c L and x dx sine theta. X dx sine theta. So we know that these photons are absorbed on the cone, traveling like that. So this will be the force acting on that strip, and the total force acting on the cone, F cone, will be integration of 2 pi r I by c L sine theta x dx. And this r by L is again sine theta, so F cone will be equal to 2 pi sine square theta divided by c into I, and the integration of x is x square by 2, and the limit will be from 0 to L. Cancelling this 2 with 2, F will now be equal to I by c into pi L square into sine square theta, and this is I by c into pi L square, and sine square theta is r square by L square. So it would be I by c into pi r square. So this will be the result when this cone will be absorbing, and in this case this will be the result when the cone will be reflecting. Okay. And now if the cone is partially absorbing, neither A is 1 nor R is 1, in fact A plus R is 1, so we can say that the force acting on the cone will be I by c pi r square, I by c pi r squared into A due to absorbed photons, and 2I by c pi r square sine square theta. 2I by c pi r square sine square theta into r. Okay, so this will be the result of where theta is the half apex angle of the cone. Half apex angle of cone. So this is the radiation pressure on the cone.